Okay, today let's talk about symmetric roots. Symmetric roots. Symmetric roots. Under symmetric roots, we're looking at sum and product. Sums and product. Okay, now so we said the general form of a quadratic equation is given by what? Ax squared plus what? Bx plus c equals to 0, right? And we say that for us to make a unity, we say that you must divide both sides by a, very important concept. So you have ax squared plus b over a, x plus what? C over a is equal to what? 0. Now, of course, we have looked at different methods to calculate and to solve to get the value of x. Of course, this is a quadratic equation, so you have two values of x. Now, let's say the roots of those equations are given. Let's say the roots of the equation are given. Let's say they are given as, let x be equals to what? Alpha, and let x be equals to what? Beta. Let's say these are the two roots of the equation. So normally, from the let's play with this. This is x equals to 4, x equals to alpha, and x equals to beta. Now, for us to get the equation that gave us these roots, we're going to, of course, bring these two together. I'm going to bring these two together. Of course, this is equal to 0. We're going to expand this because these are the root of the equation. We're going to expand this. So doing that, we have x plus x. We're having what? X squared. Then x minus this thing we're having beta minus. Then we're having minus alpha multiplied by x. We're having what? Minus alpha x. Then we're having minus alpha multiplied by minus beta. We're having positive alpha beta, all equals to 0. Of course, we're going to factor the value of x here. So we're having x squared negative bracket alpha plus beta x out plus alpha beta is equals to 0. So now we are left with two equations. Let's call this equation 2 and let's call this equation 1. So we are left with two equations that we are going to what? Compare. Of course, these two equations look very similar. We have x here, we have x here. Then we have, what do you notice? The coefficient of x in both of these equations can be collected, in the sense that, let's say from the coefficient of x, we notice that we see that alpha plus beta. Now take note. We notice that negative. Okay, and let me make this positive. Let's play with this. So let's put positive here. We're putting negative inside, negative inside. So I would like to rephrase this question, this thing, to compare it in terms of everything we have here. So let's do that. So let's compare what we have here. So let's put a positive sign here. Then we'll put a negative alpha, negative beta, and x, so that this is to exactly look like what we have here. So let's do that. So we're having a case where we have negative alpha, negative beta, of course, is equal to what? B over A. So therefore, we're going to factor out negative as we're having negative alpha plus beta is equal to B over A. You multiply both sides by negative. We see that alpha plus beta is equal to what? Negative B over A. Then now let's compare the constant C over A. The constant here is alpha beta. So comparing that, so we're going to comparing the constant. We see that what? Alpha plus beta is equal to what? C over A. So please, we have two relationships. So let's call this equation 3 and let's call this equation 4. We have relationship where we said The sum of the roots is given by negative b over a. The product of the roots are looking at what? C over a. So this is very important in a case where they say you should calculate the sum and the product of some roots of the equation, knowing this relationship. So it is very important to take note that everything was done through the comparison of how we gave. Of course, these are two roots. We say let one root be alpha and let the other root be beta. We, of course, this is normal. In cases, we have seen cases when we calculate using factorization method to find the roots. We're just like going back to that step. So we did that. We expanded it so we can look for the more of like the solution, the equation that leads to these two roots. And we had this, comparing this with what we have here as the general form to what we have assumed this would be by assuming that x is alpha and this is beta. So this is what he gave us, a case where alpha plus beta is what? Negative b over a, and alpha beta is c over a. Now let's jump into some sample problems. And the question says, find the sum and product of roots of the following equations. Find the sum and the product of the roots of the following equations. We are given the first one, 2x squared, 2x squared negative 3x plus 1 equals to 0. Second one, we are given x squared plus 6x plus 9 is equal to 0. And we're given the third one, negative 3x squared negative 5x plus 1 is equal to 0. So of course we're given three problems concerning how we can calculate the sum and the products of the following equations. So let's jump into them. So we have solution. Let's start with 1. Of course, the equation for 1, we're given 2x squared negative 3x plus 1 is equal to 0. Of course, the first step you must know, how do I say it? You must first of all write out what the value of a, b, c is. So of course we are seeing a as what? 2, we are seeing b as negative 3, and we are seeing c as 1. So we are looking for the sum and the product of the roots. So we are having for sum of roots, which is given by alpha plus beta. So we are having alpha plus beta is equals to what? Negative b over a. So we're having a case where, of course, we are seeing negative 3 over what? A is what? 2. So therefore this becomes what? 3 over 2. This is the sum of the roots. Then the product, we are seeing the product of roots, which is alpha beta. So we have alpha beta is equal to what? C over A. Of course, C is what? 1 and A is what? 2. Of course, the concept is very easy. Let's look into the second one. By giving the equation x squared plus 6x plus 9 is equal to 0. We're going to know what A, B, C is. A is what? 1 from this case. B is 6 and C is what? 9. Of course, let's look for the sum of the roots, which is negative b over a. We are still having negative 6 over 1, which is negative 6. Of course, the product of the roots, we are having c over a, which is what? 9 over 1, which is what? 9. So these are the concepts. Of course, let's look at the third one. We are given the third one. We have negative x squared negative 5x plus 1 is equal, we have 5x plus 1 is equal to 0. To know what a is. A is negative 3, b is negative 5, and c is 1. Let's look for what the sum of the roots, which is negative b over a, is equal to what? Of course, this is negative 5 over negative 3. We're having 5 over 3. Then the product of the roots, which is alpha beta, is what? C over a, which is 1 over what? Negative 3. this is equals to 1 minus 1 over 3. So this is the concept of what? Sum and product of roots. This can be used to look for a lot of expressions in symmetric roots. So please join me as we go further in this symmetric roots.